All right, let's take a look at lesson 4. All right, let's visit the challenge question for a minute. It says, the NASA data archive at the Goddard Space Flight Center contains 24 terabytes of data from previous science missions. How many CD-ROMs does this equal? If the capacity of a CD-ROM is approximately 6 times 10 to the 8th bytes, and 1 terabyte is 10 to the 15 bytes. Okay, now listen. That problem has huge numbers in it. Do you see 6 times 10 to the 8th? That's actually a special form of a number, okay? And we're going to talk more about this form in a minute. So we're going to revisit this challenge question when we understand a little bit more. Okay, so let's take a look at this table below, and let's see if we can fill it out. Okay, so the first thing is 6.98. It says 6.98, and it's multiplied by 10 to the second. So we're multiplying 6.98 times 10 to the second. 10 to the second really means 10 squared, which is 100. So you're really taking 6.98 and multiplying it by 100. We know what happens. We know we have to move the decimal point to the right 2 places. So that's going to be 698. Okay? Next, we have 6.98 times 10 to the first. That's just 10. If we multiply by 10, it moves 1 place to the right. 69.8. And now we have 6.98 times 10 to the 0. Oh, 10 to the 0. Remembering from one of the other lessons we've done, 10 to the 0, anything to the 0 power is 1. So this is really 6.98 times 10 to the 0, or 6.98 times 1, which is 6.98. Now we have 6.98 times 10 to the negative 1. Now listen, here's what's really interesting about this. If we just follow the pattern, look what's going on. Here the decimal place is at the end. Here it's before the 8. Here it's before the 9. So it keeps moving. So I almost would guarantee if you follow our pattern, this would be 0.698. But why is that so? We have to figure out what this really means. So let's go and take a look. 98 times 10 to the negative 1. 10 to the negative 1, remember, negative 1 means the reciprocal of 10 to the first. We just learned that about negative reciprocals. So this is really 1/10. So really what you're doing, 10 to the negative 1 is really 1/10. So really what you're doing is you're dividing by 10. So you're taking 6.98 and dividing by 10. We know when we divide by a power of 10, the decimal moves to the left, and it's 1 place, because there's 1 0. So that is 0.698. Because actually what you're doing with these negative exponents is you're really dividing this number. Okay? Let's look at the last example. The last example is 6.98 times 10 to the negative 2. That means 10 to the negative 2 is really 1 over 10 squared, or 1 over 100. So you're really dividing this number by 100, which means I'm moving the decimal 2 places to the left, which is 0.0698. So what pattern do I see? Well, these are called powers of 10. Powers of 10 mean that my base is 10 and I have some kind of exponent, okay? So that's a power of 10. When I multiply by a power of 10, notice this. When I have a natural number, 1, 2, 3, okay, I move the decimal point to the right those many places. This tells me don't move my decimal at all. This tells me move my decimal to the left if I have a negative exponent. So that's what I know. These are called powers of 10. This whole entire number, 6.98, I'm going to erase this for a second, 6.98 times 10 to the second, this whole expression here, this whole expression is written in scientific notation. Scientific notation is used to write very big or very, very small numbers, okay? So this is in scientific notation. This number, after we multiply it out, is called standard form. So if we take a look at the next slide in your workbook, it kind of defines for you scientific notation. Scientific notation, this number has to be between 1 and 10, including the 1. That's why it says this, right? Watch. 1 is less than or equal to the absolute value of A. We're going to talk about that, which is less than 10. And then it says n must be an integer. Oh. I left out the most important part. Hold it. Must be. Can you see that? That was bad. An integer. It gives me this little form right above it. It says A times 10 to the n. So A must be an integer. okay? And the absolute value of A must be between 1 and 10, so including the 1. So this is fine, 6.98, because it's between 1 and 10. This is also fine, negative 4 times 10 to the negative 1. N is an integer, negative 1 is an integer, and the absolute value of A, which is 4 here, must be between 1 and 10, which it is. So we can have a negative number here as well, but we can't have something that looks like this, 0.098 times 10 to the third. That is not considered scientific notation. Why not? Because this A here, this is called A is not between 1 and 10. So we need to know when our numbers are in scientific notation and when they're not in scientific notation. So let's take a look at some problems. All right, we just talked a little bit about scientific notation, and remember we said that scientific notation was in the form A times 10 to the n, which means you have two factors, okay, because these are attached by multiplication, and this X is a times, okay, a multiplication sign, okay. If that's a little confusing, you can put a dot in there, but you're not going to see the dot in most textbooks or most worksheets. You're going to see the X, okay? The A, remember, has to be between 1 and 10. The absolute value of A has to be between 1 and 10. And this must be a power of 10, which means the base must be 10 to some integer exponent. That's how you define scientific notation. So I'm going to do the first one with you, okay? I'm going to look at all the parts, all the factors. Remember, we have to be attached by multiplication, and we are, okay? Now I'm going to look here. This number has to be between 1 and 10, and it's not. Okay, that number is less than 1. Therefore, this is not scientific notation. This factor is fine because it's a power of 10, but here we lose it. So this is not in scientific notation. Not scientific notation. So that's all I'm asking you to do. I'm not asking you to multiply. I'm not asking you to do anything else. Just inform us if these are in scientific notation. So I'm going to ask you to do 2 through 6. Stop the video. Do 2 through 6 in your workbook, and then we'll go over them. All right, how do you think you did? Let's take a look. All right, 62. Well, there's already a problem, isn't there? 62 is not between 1 and 10. So this is not in scientific notation. Okay? And 4.21 times 10 to the negative 4. Well, let's look at the 4.21. That number is between 1 and 10, so that's fine. That's a base of 10 to an integer exponent, so this is all good. Attached by multiplication. So yes, this is in scientific notation. All right, let's take a look at number 4. 1 times 10 to the negative 8. 1 is fine, because remember, it's got to be between 1 and 10, including the 1. So that's fine. It's attached by multiplication. Base is 10 to an integer exponent. So this is another yes. So this is in scientific notation. How about this? Well, this is okay. The first factor is okay because that's between 1 and 10. We have attached by multiplication, so that's good. But here's the problem. We cannot have a base of 4. It's got to be a base of 10. So this is not in scientific notation. Okay, so that's no good. All right, last one, negative 6.8. We have to make sure the absolute value of this number is between 1 and 10, and it is, because the absolute value of negative 6.8 is 6.8. So that's okay. That's fine. That factor is fine. It's attached by multiplication. Great. And that is a power of 10 to an integer exponent. So yes, all of these are in scientific notation. Okay? In the next slide, we're going to ask you to express some examples in standard form. All that means to do is to take it from scientific notation and multiply it out. Remember how to do that. I'm going to show you right here. If we take this one and put it in standard form, it means that we look at the exponent, and if it's negative, we move the decimal to the left that many places. Of course, I picked a big one, all right, but here's your decimal, 1 point. We want to move it 8 places to the left. I'm going to move this over so I have enough room to move it 8 places to the left. Okay, I'm going to have to add 7 zeros. There's one place, but now I have to start adding zeros. So it's 7 zeros. 1, 2, 3, 4, 5, 6, 7, and there's your 1, right? Because 1, 2, 3, 4, 5, I missed one, sorry. 1, 2, 3, 4, 5, 6, 7, 8. When you get older, you start seeing lots and lots of zeros when you look at zeros. Okay? Yeah, look forward to that. Anyway, so that's my number in standard form. That's my number in scientific notation. So just do the next 3, put them in standard form, and we'll revisit that. All right, here we go. Let's see how you did. Positive exponent, we're going to move the decimal 5 places to the right. So we're going to take 2.451 and we're going to move it once, twice, 3 times. We're going to have to add 2 zeros to make 5 times. So 245,100. Take the decimal out of the number because the decimal is now here. Don't keep the decimal there because then you haven't changed the number. Okay? So this is your final answer in standard form. Okay? This guy, we have a negative exponent, so we're going to move the decimal to the left that many places, which is 3. So we have 7.31. Here's 1, 2, 3. So 0.00731. That is your number in standard form. Pretty easy, right? The last one, that just means don't move at all. No spaces, no spaces. Because remember why? We're multiplying by 1. So your answer there is negative 5.5. So now we know the difference between standard form and scientific notation. We know what it means for a number to be in scientific notation. Now we're going to figure out how do we take a number and put it into scientific notation. So that's what we're going to do next. All right, this number is 640. It's really considered standard form. I'm going to put this number in scientific notation. So you can follow the steps that are in your workbook and on your slide, but here's how this works. I'm going to put my decimal point. Remember, it's here right now. This is where it is right now. I'm going to put my decimal to the right of the first non-zero digit. So the first number that's reading from left to right, first number that's not 0, that's where my decimal is going to go to the right of. So if I write this number, 6, okay, that's the first digit that's not 0. I want my decimal to be right here. Maybe I'll make an X right there, okay? So that's where I want it. Now I have to say to myself, listen to this. This is the hard part. This is the part I didn't do very well a long time ago because I'm a little dyslexic. So this made me crazy. But here's what I have to say to myself. I have to say to myself, self. Yep, I did say that. Self, how many times do I have to move my remember, because remember now it's times 10 to some power. Here's how you get the power. How many times do I have to move this where I want it back to where it was, back to the original? So here's where it was. Whoops. Here's where it was. It was right there. I have to move it 2 places. And I have to, look, to get it back where it was, I have to move it 2 places to the right. That makes it a positive 2. The biggest error people make is they say, oh, I want it here, well, I moved it 2 places to the left. That's wrong, because I have to get it back to the original. So my number now is 6.40 times 10 to the second, because I had to move it to the right to get it to the original number. So this number is my answer in scientific notation, and I can check that. I can check that by multiplying. If I was to multiply this, I'd have to move the decimal 2 places to the right. If I move the decimal 2 places to the right, I will get back to this number. That's how you check it. Now listen, as a dyslexic, that made me absolutely crazy. I always wanted to put a negative when it was positive and a positive when it was negative. So I'm going to give you a little, well, I'm not going to give you a hint yet. Wait till we do this one. Maybe you can give me the hint. Okay, so that's the answer to that problem. That's that number in scientific notation. So these mean the same exact thing, only one's written in scientific notation and one's written in standard form. Okay? All right, take a look at this one. So the first thing we do is we put the decimal to the right of the first non-zero digit. I was looking for my blue pen if you're looking at me looking everywhere. Okay, to the right of the first non-zero digit. Well, the first non-zero digit, that's 0, that's not 0, non-zero. That's where I want it. I want it right there. Okay, and again, I'm going to make it almost look like an X kind of guy. Okay. So I'm going to do 9.8. I don't need these zeros in the front. When I put zeros in the front, they're meaningless. So 9.8, and remember, it's times 10, and I got to figure out what power. Now, here's the deal. Remember, I have to take it back to the original. Well, this is where I want it, because I need it to be between 1 and 10, and now it's between 1 and 10. But I have to get it back to the original. 1, 2, 3. And notice I'm going to the left, so that is a negative 3. So it's 9.8 times 10 to the negative 3. That's that number in scientific notation. Don't believe me? Check. If I multiply this, I have to take it 3 places to the left. So 3 places to the left would be 1, add 2 zeros. And that's my original number. I'm just writing my original number in another way. Okay, so do you think you know the little trick I was going to tell you? here's the little trick. And this is in your notes. I'm not going to write it down, okay? If the given number, this is the given number, is bigger than 1, you're going to have a positive exponent. If the given number is less than 1, this is less than 1, you're going to have a negative exponent. I like that because then I don't care which way I'm moving it. I just put it where I want it and count. I don't have to worry, is it negative, is it positive? That's too hard for me. So this makes that a lot easier. The given number is bigger than 1, positive exponent. Given number is less than 1, negative exponent. Makes it a lot easier to deal with. So that's how you do it. On your next slide, there are 6 problems. Okay? I want you to try 1, 2, or 3, believe it or not. 1, 2, and 3, believe it or not. And then I'm going to come back and go over those and do 4, 5, and 6. In number 3, it's negative. Don't worry about the negative. When you put the number in scientific notation, forget about the negative and then just bring down the negative. So try those. All right, let's see how you did. Let's go to number 1. Okay, that number is bigger than 1, so I have to tell you, I already know that I'm going to have a positive exponent. And you know what? I'm going to make that box just a little bigger, just in case you can't see that. Though I do have a new handy-dandy marker. It's a positive. That's to remind me it's positive. Okay, now here's what I want to do. I want to put this decimal, remember, to the right of the first non-zero digit, and that's right there, 3.68. Remember why I want to do that. That puts it between 1 and 10, okay? So it's 3.68, and now I have to say to myself, how do I get it back? Well, I get it back to the original by moving 1 spot, so it's positive 1. So it's 3.68 times 10 to the first, okay? And I knew it was positive because that number is bigger than 1, but I can tell it's positive because I have to move 1 to the right to get back to the original. So, okay, it's just a little bomb. Oh, it's my marker top. Okay, here we go. Positive or negative exponent? Yes, it is a negative exponent because it's less than 1. This number, this given number is less than 1. So it's a negative exponent. Okay, so now I want it to the right of the first non-zero digit, my decimal. So 0 is a 0, 0 is a 0. Here's 4. 4 is not a 0, so that's where I want it. If I want to write 4.0, I can. I don't have to. Okay, but I want it here. I want it right here. How do I get it back to the original? 1, 2, 3. So it's 4 times 10 to the negative 3. Done. Okay? How about negative 68? We said this would be the hard one. Don't worry about the negative till the end and just bring it down with you. Okay, so to the right of the first non-zero digit. So we want it in 6.8 times 10. And what do you think about this one, positive or negative? It's going to be positive. Remember, don't worry about the negative. Don't think about the negative because the absolute value of that number is greater than 1. So that's going to be positive. And then we want it here, 6.8, but we know it's, so we want it here, but we know it's really here. So it's one place. So it's 6.8 times 10 to the first, but bring the negative down. So do it as if the negative is not there. Because think about that. If I check that, it's going to move the decimal to the right one place and give me 68, which is where I started that problem. That's 68. So there we go. All right, ready for this one? Well, so deal with this one. This one already is between 1 and 10. So in scientific notation, I don't want to move it at all. That's where the 10 to the 0 comes in. 7.6 times 10 to the 0 is that number in scientific notation because it already is between 1 and 10. So nowhere to move that. Okay? 0.43. 0.43 is going to be a negative exponent because it's less than 1. Okay, it's going to be a negative exponent. I didn't even box that in. Okay. All right, it's going to be a negative exponent. And where do I want the decimal? Well, I want it as 4.3. I want it right there, but it was here. So I have to move it 1 to the left. So it's 4.3 times 10 to the negative 1. And again, you can check your answer by multiplying it, putting it back in standard form, and that'll work out. Okay, here's my most fun. You ready? All right. I'm actually going to move this over so you can see it better. I'm going to erase this just to give me a little more space. Those can stay on the board for a second. And it's 0.6 times 10 to the negative 2. You actually have two choices. You want your choice number one? Choice number one is to just multiply this out first, because this is clearly not in standard form. Okay? Sorry, not in scientific notation. It's not in standard form either, but it's not in scientific notation because that's not between 1 and 10. So you have two choices. One choice is to multiply it out first. First, put it in standard form. And you would go 2 places to the left, so 0.006. And then take that number and put it in scientific notation. Okay? And if I did that, I'd want the decimal here, so that would be 6 times 10, but I have to get it back to the original, so it'd be -3. So I could do that. This might be a better choice. Watch. And when you do this, you're using some other rules of exponents. So this is why I like this kind of choice. Here we go. What I see here is I really need to put that in scientific notation. So watch. I'm going to pretend that's not there for a second. And I'm going to go 6 times 10. We want the decimal right here. We'd have to move it once to the left to get it back. So that's -1 because my original number, 0.6, is less than 1. But what do I already have there? I already have there times 10 to the -2. Well, what do I do with that? Well, that's simple. That's multiplication property. Keep the base, add the exponents. -1 plus -2 is -3. And that is the same answer you just got. So notice what I did. I wrote this in scientific notation, pretended that wasn't there. Put that back in there, keep the base, add the exponents. Pick your own poison. Either way you want to do it is fine with me. Okay? Now, I want you to take note of one other thing while we're here, and this is in your workbook, is the fact that it's okay to have negative exponents. Scientific notation is really pretty much one of the only places it's okay to have negative exponents. If you recall before, when we had things like this, a to the 1, b to the -3, we moved them to get them positive. That was our goal then, because it's important to have them positive with expressions. But scientific notation is just another way to write really big and really small numbers. So we have to have a negative exponent if it's a really small number. So they're okay there. Negative exponents are okay, but only in scientific notation. Our goal is important. Our goal in scientific notation is to get everything in the numerator. For instance, I could write this like this. Bring it down. But that's not our goal. Our goal in scientific notation is to have everything in the numerator. So negative exponents are okay. All right? Because remember two factors. The 6 has a positive exponent that stays up. That has a negative exponent that would go down. But I don't want to do that here. I would do it with my variables, but not with scientific notation. Let's see why as we continue. All right, I want to take a look at these. And before we talk about how to do them, I want to talk about how they're similar. Or if they're similar, you're going, they don't look similar. But the truth is, they're almost exactly alike. Watch. Ready? Watch. Coefficient times base to an exponent times coefficient times the same base to an exponent. Coefficient times base to an exponent times coefficient times that same base to an exponent. I just said the same thing. Coefficient times base to an exponent times coefficient times base to an exponent. Coefficient times base to an exponent times coefficient times base to the exponent. I said the same thing. So let's talk about how we find the product. If you know how to find the product of this, then you have to be able to know how to find the product of this. So you ready? Okay. All you do here is multiply the coefficients. We get 10. 5 times 2 is 10. Then y times y to 6 times y cubed. Remember, keep the common base, and we have a common base. Add the exponents, and we get 9. 10y to the 9th. Okay? So we do the same thing here. Multiply the coefficients, which is 8.3, and this is on the next slide, you'll see in your workbook. 8.3 times 1.1, which is 9.13, okay? Times 10 to what power? Why? How do I know it's 10? Keep the common base, 10, add the exponents. 4 plus -2 is 2. So we are done. Same thing, okay? And that's all you do for multiplication with scientific notation. So easy. And you're saying, well, wait, why don't I just do this like by hand or by calculator? I have a calculator. So I have a big number. Why can't I do the big number by calculator? Because calculators only can display so many digits. This is a better answer than your well, this is not this would be easy on a calculator because it's not a big number. But if you had really, really big numbers, scientific notation is better because it's not as bad on the display. Okay, so we did multiplication. Let's look at division. All right, we're going to do division now. Now, there's two ways to handle division. There's everybody else's way and my way. So method one is everybody else's way. And you can look at method one. The steps are right there for you. I'm going to do method two. And if you recall, there was a method one and method two last time, and I liked method two as well. Method two is the method I like here. So here's what I'm going to do. It's very simple. First thing you do, and in scientific notation, if you recall before, when we had a division line with the letters, we really just simplified. Scientific notation is different. You must divide because you want an actual answer. Well, luckily, I picked really easy numbers to divide. 8 divided by 4 is 2. And now here's what I'm going to do. I'm going to move, and I'm allowed to move. I'm allowed to cross the line because I have factors. I am going to move the power of 10 on the bottom up. I'm always going to move the power of 10 on the bottom up. Why am I going to do that? I'm going to do that because the whole point of scientific notation is to get the answer in the numerator. So I am not moving it because it's negative. I am moving it because I need my answer in the numerator. So even if this was positive, I'd be moving it. But when you cross the line, you change the sign of the exponents. It's going to look like this. You ready? I'm moving this up. And I'm going to get times 10, because once you move it up, now it's attached by multiplication, just like before. Instead of negative 3, it's positive 3. If that was a positive, when we moved it up, it would become negative. Now I keep the base, add the exponents. And the reason I do that is because I'm afraid, a lot of times, that people will go 5 minus 3 is 2, when it's really 5 minus a minus 3, which is 5 plus 3, which is 8. Okay? So you can do that, and that's fine, but I like to move it method 2. So I'm going to deal with method 2, okay, and that's all you do. Now I think we have enough information to answer the challenge question. The NASA data archive at the Goddard Space Flight Center contains 24 terabytes of data from previous science missions. How many CD-ROMs does this equal if the capacity of one CD-ROM is approximately 6 times 10 to the 8th byte? Now, 1 terabyte is 10 to the 15 bytes. What the heck does this all mean? Here's what this all means. Okay? I know I have 24 terabytes of data that I want to get on CDs. I want to know how many CDs I need. Well, I know that one CD holds 6 times 10 to the 8th bytes of data. Okay? Bytes of data. Okay? And I know 1 terabyte is 10 to the 15 bytes of data. So first thing I have to figure out is how many bytes of data I have total, and then I have to figure out how many CDs I need to hold all those bytes. So I know I have 24 terabytes, okay, but 1 terabyte is 10 to the 15th. So I have to multiply 24 times 10 to the 15th. And that's what I get when I multiply 24, and that looks really terrible. And that's what I get when I multiply 24 by 10 to the 15th. That's it. I'm going to leave it like that, scientific notation. So this is how, actually it's not scientific notation yet, so hold on. But it is in, that's what how many bytes of data I have. Now, that's how many bytes of data I have. One CD-ROM holds 6 times 10 to the 8th bytes. So I have to know how many CDs I want, so I have to divide, okay, because I want equal shares on all CDs. Now, I know that this is not scientific notation, but to be honest, I don't care. I'm going to tell you why I don't care. When I'm dividing, okay, I can divide when they're not in scientific notation, and in the end, I'm just going to give you an answer that's in scientific notation. The reason I won't change this now is because sometimes after you divide, your answer is in scientific notation. That's all you want anyway. So you don't have to change that to scientific notation. All right, remember, we're looking for how many CDs we need. So this number is, again, not in scientific notation, but that's okay, as long as our answer is at the end. So 24 divided by 6 is, and I'm going to leave you a little bit more space here. 24 divided by 6 is 4 times 10. And remember, I'm going to bring this up. That's my method. I'm going to bring it up. And when I bring it up, cross the line, change the sign, we get 4 times 10 to the 7 CDs. Well, that's nice. That's a lot of CDs. How many CDs is it? Well, now, you can leave it like that, but if somebody told me I want 4 times 10 to the 7 CDs, I mean, I've never seen anybody say that. You'd probably want this in standard form. In standard form, that tells me I have to multiply 4 by 10 to the 7th, or move the decimal 7 places to the right, or add 7 zeros. 1, 2, 3, 4, 5, 6, 7. Okay? So that's how many CDs I need. That's a ton of CDs, lots and lots of CDs. So that's the end of this question. So I can either leave it like this or like this. Doesn't matter, but that's how you do that problem. All right, these two are in your workbook. There's a multiplication and there's a division problem. You try these, okay, and then please try them. Stop the video, try them yourself in the workbook, click the video back, and we'll go over them, okay? We'll do that in a minute. Okay, how do you think you did? How much money would you bet on your answers? All right, here we go. We're going to multiply. 3.61 times 2.1. That's what we're going to do first. Okay, and that's 7.581. Okay, keep the base. Add the exponents. Negative 18 and negative 31 is negative 49. So this is, now that's a huge number. You'd have to add 48 zeros. Can't do that on a calculator. All right, so that one's done. All right, remember, negative exponents are okay. Take a look at this one. I have to divide, so I'm going to divide 4.61 and 2. When I do that, I get 2.305 times 10. Remember what I'm going to do? I'm going to bring this up, cross the line, change the sign of the exponent, okay? And I get negative 3, because negative 7 and a positive 4 is negative 3. And I am done here. There are 3 more examples left, and the other 3, they're just not written in scientific notation. So what I'd like you to do, don't cheat, multiply them, and put the answer in scientific notation. That's not what you're supposed to do. Put all the numbers in scientific notation, and then do the problems, okay? And then click back on when you're ready. All right, I'm hoping you didn't cheat here. Here we go, 70,000. That number is bigger than 1. It's going to have a positive exponent. So it's going to be 7, because that's where we want the decimal, and 1, 2, 3, 4. So 7 times 10 to the 4th, okay? Times, this is going to be 1 times 10. It's going to be a negative exponent because it's less than 1. 1, 2, 3, 4. Negative 4, okay? So that's what we have there. All right, so we have 7 times 1 is 7, times 10 to the 4 plus negative 4 is 0. The answer to this problem is really just 7, okay, 7. So 7 times 10 to the 0 in scientific notation. In standard form, the answer is 7. You are done, okay? All right, take a look at this one. All right, we're going to divide. We're going to put this in scientific notation. They're both going to get negative exponents because they're both smaller than 0. And we have 9 times 10, because we want the decimal here, 1, 2, 3 to the negative 3 power, divided by 3 times 10 to the negative, we want the decimal here, 1, 2, 3, 4 power. Right? That's it. First to put them in scientific notation. Now I'm going to bring this up, because that's my method, right? Times 10 to the 4th. Cross the line, change the sign. You're not bringing the number up, you're just bringing the factor of 10 up. 9 divided by 3 is 3. 3 times 10 to the, I owe you 3, I have 4, so I have 1. So the answer there is really just 30, because 10 to the 1st is 10. 3 times 10 is 30. So in scientific notation, it's 3 times 10 to the 1st. In standard form, it's 30. All right, last one. These are both going to be negative exponents. We want it after the 2, first non-zero digit. 1, 2, 3. That's negative 3. This is 4 times 10 to the negative, right? It's negative exponent. We want it here. 1, 2, 3, 4. This is 2. 2 divided by 4. 2 divided by 4 is 0.5. 0.5 times 10. Bring this up. It's to the 1st again. Now, this is not in scientific notation or standard form. I'm going to put this in scientific notation. Here's what I'm going to do. This is 0.5 would be 5. 5 times 10. Remember, it's going to be a negative exponent. Assume that's not there for a minute. Okay, to the negative 1. But there is a 1 there. So it's 5 times 10 to the 0. So the answer to this question is 5 times 10 to the 0, or just plain 5. Okay, and you're done. So the goal is to first write them in scientific notation, and then to work them out in scientific notation. And in the end, you can either leave your answer in scientific notation or put it in standard form. That's up to you, unless your directions to give you some way to have the answer. But either way is fine with me. All right?